Hi everyone. So today we'll enter chapter 4 on continuous random variables. So in the previous chapter I sort of like showcase a little bit what is this continuous random variables all about. So for discrete random variables, so what do we know about discrete random variables? Basically, we know that, for example, if you have a binomial distribution, so you are given two parameters, and if let's say you are given the Poisson distribution, you are given one parameter. But the point here is that basically what you have is some uh, frequency table or probability distribution. So this is small x, this is the probability. So let's say this is 0, 1, 2, 3, and so on. And for each of the values, you are given the probability. Let's say this is P0, P1, P2, P3. And previously, we also, in S1, basically we sort of touched a little bit about all these P0, P1, P2, and P3, and so on. So this can be given by a function called the probability mass function, whereby you are given a function and then you give the values of let's say x equals to 0, 1, 2, and 3 will determine the probability. So so like for example, for the Poisson distribution, we have this kind of formula, lambda x and then x factorial. So we have this kind of formula. So this formula by itself is what we call as the probability mass function. And we sort of want to generalize it for continuous random variables. Okay. So we take note that for discrete random variables, there are two things which are very important. The first one will be the expected value. So expected value is given by the sum of all I, xi, pi. So now if let's say this particular pi is given by your probability mass function, then later on when you look at the continuous random variable ones, those will be also substituted by the what we call as the probability density function. So for the variance of x, it is usually given by the sum of all I, xi square pi minus ex squared. So these two formulas are what we learn for discrete random variables. So now for continuous random variables, we also have this, and you have already seen these two forms if you look at the previous chapter's video. So before I review what is the form again, so let us begin with the continuous random variable version of probability mass function, which is called the probability density function. So probability density function is the continuous random variable version of probability mass function. So remember that probability density function is for continuous random variable. And probability mass function will be for discrete random variable. So now let's begin with the idea of probability. So what are the properties? So the first thing, the properties. We know that probability cannot be equal to 0 because if let's say it is equal to 0, sorry, I repeat again. Probability cannot be negative. It can be 0, but it cannot be negative. So because if probability is negative, it is not defined. So let's say the PDF or the probability density function, I denote it as P of X. So then the first property will be your P of X has to be greater or equal to 0. It can be 0, but it cannot be negative. The second property would be when you integrate on the given domain. So right now the domain that I'm writing is from minus infinity to plus infinity, but in reality this depends on the domain that they give you. So if you integrate across the domain of the defined domain for Px, this has to be equals to 1. So this actually corresponds to the sum of all probability for discrete random variable to be equals to 1. Okay. So then for continuous random variable, you don't really have this kind of discrete values of probability, because so this is equal to 0. In the next probability probably you will see why this is the case. So rather I would probably define first. So what is happening? So if let's say you have x between a and b, so this usually is written as something like this. So you are integrating your px from a to b. So this is by definition. And after having this kind of definition, you see exactly why you cannot have this, because this particular probability will be integrating from a to a, px dx, and we know that this is 0. And because of the fourth property, it also means that your x between a and b, not including a and b, they are actually the same as including either of the endpoints. Why is that the case? Because basically speaking, your endpoint does not matter for continuous random variable. So all these four are equal and they are the same as integrating from a to b, px dx. So now let's define something. Actually, this chapter is not that long. So after I introduce all the definitions, basically that's it. So let's introduce some definitions. So what is the definition of, for example, the first quartile, the second quartile, which is the median, or the third quartile, and so on? So previously we said that if it is the first quartile, basically you divide your data into 4 parts, and the first quarter will be your first quartile, and then the first 2 quartile that particular value will be your second quartile or the median. The first 3 quartile add up together, that particular value will give you the third quartile. So something like this. Let's say this is your data. So, okay, let's say this is your data set. You have 8 squares. So how do you find your first quartile? Basically, you divide your data set into 4 parts. So this will be your first quartile, this will be your second quartile, this will be your third quartile. So that's how you find Q1, Q2, and Q3 for a discrete data set. But if let's say this is your continuous random variable, so your Q1 will be defined by, so this depends on your domain as well, but generally speaking, you start from the lowest value of your domain. Let's say this is minus infinity, up to some point, such that this particular integration gives you 1/4. So K will be your first quartile. Similarly, if let's say you have the integration starting from the lowest point of your domain up to 1/2, for example, so then your K will be your median, Q2, and so on. So then this is quite flexible because you can define, for example, 80 percentile, you try to find the value. So basically you just substitute the probability to 0.8 and then find that particular value that reaches to 0.8 for the probability. Okay? So this is the first definition. The second definition will be your expected value, which you might already seen from the last video. Basically, this will be integrating from the smallest part of your domain to the largest part of your domain. Sorry, this is px. And then you integrate px multiplied with x. So notice a similarity with the discrete version. So the summation becomes integration. Your x is still there. Your pi becomes a function, which is px. Then the variance will be the same thing. This will be integrating from minus infinity to infinity. So you have x squared px dx minus ex squared. So these are the definitions that you need to remember. So the way you use it, we'll look at the examples right now. So let's look at the examples that I've prepared. Let's say you have a continuous variable x having the following probability density function. You want to show that fx has properties of a probability density function and sketch fx. So whenever you see this type of questions, the first thing that you need to show is your fx is greater or equal to 0. The second thing is that you need to show that when you integrate your fx across your whole domain, this has to be equals to 1. So looking at the particular equation, for the first part, which is when your x is between 1 to 2, basically the smallest value will be 0 when x equals to 1. So f1 gives you 0. In this case, you are sure that the first portion of the equation, they will really non-negative. Then you look at the second portion of the equation. When your x is 4, this is also 0. So this means that basically your function is strictly non-negative. So that's how you show the first point. Second point, how do you show this? So now the domain given is from 1 to 4. So what you will need to show is that integrating from 1. So this is a piecewise function. So from 1 to 2, you have to integrate 2x minus 1 divided by 3 dx. And then from 2 to 4, you need to integrate 4 minus x divided by 3 dx. And you need to show that this is equals to 1. So this will be 2 over 3. So you would get x squared over 2 minus x. So this is from 1 to 2. And then you have 1 over 3. So you have 4x minus x squared over 2. So now let's substitute the values inside. You have 2 over 3. 2 minus 2 minus 1 over 2 plus 1. So here you have 16 minus 8 minus 8 plus 2. So now sum everything up. So the first part, this one cancel off, and then 1 minus half, you get half. Half you divide by 2 over 3. So you would get 1 over 3. Second one, you have 2 over 3. So this is 1. So now you prove it. So okay, you need to sketch fx. So what do you need to find? You need to find 3 points when x equals to 1. So when x equals to 1, we know that this is 0. When x equals to 4, we also know that this is 0. So what you need to do is to find what happens when x equals to 2. So from the first portion, this would be 2 minus 1, 2 over 3. Second portion, 4 minus 2, you also get 2 over 3. So if you want to sketch it, it will be like this. So there's no point for you to draw the negative portion because you know that it will not go below the x-axis. So when it is 1 to 2, so let's say this is 1, this is 2, and then 2 to 4. So this point here would be 2 over 3. So that would be your fx. So the second one, find px smaller than 3. So this will be equals to integrating from the lowest point of your domain, which is 1, up to 2 because of the piecewise function. So you always need to take care of the piecewise function accordingly. And then from 2 to 3. So this will be 4 minus x over 3. dx. So from the exercise above, we know that the first portion gives us 1 over 3. So what we need is the second portion. You have 1 over 3, 4x minus x squared over 2, 3, 2. So this is 1 over 3 plus 1 over 3. So 12 minus 9 over 2 minus 8 plus 2. So just sum them up. So this is 1 over 3 plus 1 over 3 multiply with 3 over 2. So then you get 1 over 3 plus 1 over 2, which is 5 over 6. So part C. Find the value of k such that it is 1 over 3. So px smaller than k is 1 over 3. And we already found it. This thing gives us 1 over 3. That's why k will be equals to 2. Second question. Jenna and Alex share the use of a car. Jenna used 70% of the time, Alex 25%. After Jenna used the car, number of liter will become that. Alex used the car, number of liter will become that. Not knowing who used the car last, check the amount of fuel, find the probability is less than 20 liters. So what you need to find is basically Px less than 20. So then you have two chances. So the first one is if let's say Jenna is using it, 0.75, then you would need to integrate from 15 to 20, 1 over 50 dx. So this is the first part. If let's say Alex is using it, then you need to integrate from 0 to 20, 1 over 25 dx. So this will be 0.75 divided by 50. Basically just x 20, 15 plus 0.25 divided by 25. Then x from 0 to 20. So 0.75 times 5, 20 minus 15 is 5, and then divide by 50. 0.25 times 20 divided by 25. So calculate that one out. I'm calculating this now. So this will give us 11 over 40. Okay. Third question. Mia breaks the glass at the rate of 4 per week. If t is the time, then in weeks between successive breakage of glasses, then you are also given the probability density function. So you are asked to calculate what is the probability that 1 week goes by, Mia did not break any glass. So here you are given two probability distribution. The first one is a Poisson because you are just given one parameter. So the first one is what we call as the Poisson distribution. Rate is 4 per week. Second one is a continuous random variable. So look at what the question asks you. The question asks you that you want to find probability a week goes by without me breaking any classes. So which one makes sense? One is discrete. This one is continuous. Previously, we already said that for continuous random variable, you cannot have something like this because this will give you 0. So this is for continuous probability distribution. So then it means that we should not use FT because it doesn't make sense. So then what you're left with is basically using the discrete version. So if you break 4 per week, so basically what you're asking is you break 0, you need to find the probability of Mia not breaking anything within the week. So this is a Poisson distribution, so it will be e to the power of minus 4 and then 4 to the power of 0 and then 0 factorial. So this will be just e to the power minus 4, which is 0.01832. So that's how you calculate the probability. The fourth question, patients arriving at dental surgery, they will wait. So the duration is modeled using the probability density function. Sketch the graph and then show that k is 242. So this is just straight line going up. When t equals to 0, k is also 0. So this is just literally straight line going up and up to 22. So this is ft, this is t. So you need to show that k equals to that number. So basically integrating from 0 to 22 of kt dt has to be equals to 1. So k I can factor outside. After integrating t, I get t squared over 2. So you integrate from 0 to 22, this is equals to 1. So 22 squared divided by 2, that will be 242. 0 basically is 0. So therefore k equals to 1 over 242. So you show this. Find the probability that a randomly chosen patient waits more than 5 minutes. So then this will be px more than 5. So it will be integrating from 5 to 22. 1 over 242 t dt. So you have 1 over 242 t squared over 2 integrating from 5 to 22. So that will be 1 over 242 multiply with 22 square divide by 2 minus 25/2. So this gives us 0.9483. Or if you want to write it as a fraction, this will be 459/484. Part C, dental surgery claim that 80% waits for less than 20 minutes, show that the claim is justified. So basically what you need to show is that if it is 80%, you need to show that the time is more than, you need to show that the claim is justified. So you need to show that at 80% of a probability, it is indeed less than 20 minutes. So then what you can do is to start integrating from 0 to k. So this will be 1/242 times t dt. And this has to be 0.8. So if you manage to show that your k is less than 20 minutes, then you're done. So you have t squared over 2 k0, and this is 0.8 times 242. So you have k squared equals to 2 times 0.8 times 242. Sorry, hopefully I didn't mess up the mic. So this is 387.2. So k will be the square root of that, 19.6774 minutes. So the reason why I directly discarded the negative portion is because you don't have negative time. So therefore, the claim is justified. Since k is less than 20. Question 5. Time to failure of a particular toaster in years can be modeled by this. Find the probability that this type will fail between 3 to 18 months. So what you need to do is to first you need to look at the time. Time is calculated in years and they give you in months. So 3 months will be 3/12 year. 18 will be 18 divided by 12 year. So then what you need to find is to integrate from 0.25, which is 3 divided by 12, up until 1, and then plug in the first part of the equation because that's what relevant. Then starting from 1, so 18 divided by 12 is 1.5, which is less than 1.69. So you have 1.5 over here, and then you have 5/6 square root of x dx. So now this is integration time. This will be x plus 2x squared, 0.251 plus 5/6. If you can't do this, convert it to the power form first. So 1 over square root x is x to the power of minus 1/2. So let's evaluate the first part first. 1 plus 2 minus 0.25 minus 2 times 0.25 square so this is 0.125 plus 5 over 6. So over here this will be x 1 over 2 minus 1 over 2. And then you have 1.5, 1. So then the first part will be 3 minus 0.25 minus 0.125 divided by 6. So this is 7 over 16. So square root of 1.5 times 2 and then minus 2. So this is 0.4495. So finally calculate everything. It will be 0.8121. Okay, so that's how you find the answer for part A. Part B, store sells 1006 of this type, 1 year warranty. What is the expected number of toaster that will fail? So part B. So first you need to find what happens after 1 year. So integrating the same thing from 0 to 1, 1 over 6, 1 plus 4x dx. So this will give you 1 over 6 x plus 2x squared 1 0. So when you substitute 0, you know that this is 0. So what you have is 3 over 6, which is 1 over 2. So this is a probability that within 1 year the toaster will fail. So then you want to find how many toaster will fail. You just use 1006 times 1 over 2, which is 800. So those will be your expected value that it will fail during the warranty period. Question 6. Forester packs kindling in bags to sell. The mass will be given by that probability density function. Show that k equals to 1 over 70. So integrating from 3 to 5, k I can put it outside. 3x squared minus 4x plus 2 dx equals to 1. So integrating the whole thing, this will be x cubed minus 2x squared plus 2x. Then substitute the value of 3 and 5 inside. So this will be 1 to 5 minus 50 plus 10 minus 27 plus 18 minus 6. So this equals to 1. So then do the operation. So this will be 1 over 70. Samuel buys a bag of kindling. What is the expected mass? So if you want to find the expected mass, this will be Ex, and this is the same as integrating from 3 to 5. X, sorry, you have the coefficient of k. So you have x, multiply everything inside. So now let's start multiplying that. And integrating it. Then substitute the value of 3 and 5 inside. So 5 power 4 times 3. That will give you 1875 divided by 4 minus 4 times 5 power 3. 500 over 3 plus 25 minus 3 power 5 divided by 4. 243 over 4 plus 4 times 27 divided by 3, 36 minus 9. So count that. So this will be around 4.19 kg. Forester has 100 bags of kindlings, $3 with mass 4 kg or more, $2 otherwise. So find the amount, expected amount for these hundreds. So what you need to do is to divide your probability into 2 parts. So 4 or more. So if x is more than 4, so this will be 1 over 70. Integrating this from 4 to 5, because 5 is your upper limit. So 3x squared minus 4x plus 2 dx. This will be 1 over 70 x cubed minus 2x squared plus 2x 5, 4. So I will directly evaluate that. Minus 4 power 3 plus 2 times 4 square minus 8. So this will be 0.6429, or it is 9 over 14. Let's keep the exact value for the moment. So then otherwise will be, so you don't need to integrate twice, because otherwise will be, let's put it this way, otherwise will be px smaller than 4, will be 1 minus 9 over 14, and this will be 5 over 14. So if it is more than 4 kg, charge $3. So 9 over 14, you will charge with $3 and you have 100 bags. If it is otherwise, you charge $2. So this will be around 264.29. This will be the answer. Question 7. Environmentally developed index for the quality of pond. So it is given by that probability. So find the expected value. You just integrate from 0 to 1. So multiply everything with x. So you have x squared minus 2x cubed plus x power 4 dx. So this will be x cubed over 3 minus x power 4 over 2 plus x power 5 over 5. And you just evaluate it. So it is 1 over 3 minus 1 over 2 plus 1 over 5. Then you multiply with 12. So this will give us 0.4. They will survive best in ponds when the quality is 0.8. Check a random sample, how many will survive best. So greater than 0.8. So it will be 12, integrating from 0.8 to 1. So this will be x minus 2x squared plus x cubed dx. This will be x squared over 2 minus 2x cubed over 3 plus x power 4 over 4. Then you substitute the values inside. 1 over 2 minus 2 over 3 plus 1 over 4 minus 0.8 squared divided by 2. 0.32 plus 2 times 0.8 power 3 divided by 3. So this is 0.3413. 0.8 power 4. So minus 0.4096. So do the calculation. There will be 1 over 2 minus 2 over 3 plus 1 over 4 minus 0.32 plus 0.3413 minus 0.4096. So judging from my calculation, I probably calculate something wrong. Let me recalculate. Okay, let's do this more carefully. So this is 1 over 12. The first one is 8 over 25. Second one is 2 times 0.8 power 3 divided by 3. So you have plus, then the last one should be minus. Which is this. Okay, I understand why. The last one I calculated it wrong. It should be 1024. Alright, so this will be 0.0272. So now you check 150. So 0.0272 times 150. This will be about 4.08. So you round it up to 4. Yep. So that is a solution. The last question. Machine produce a component for industrial use. So the acceptable length are given by that particular PDF. Find the mean and standard deviation. So the mean would be to integrate from 1 to 3 10x squared minus x power 4 dx. So this will be 10x cubed over 3 minus x power 5 over 5. You integrate from 1 to 3. So let's do this properly as well, so that I don't make any mistakes. Ten times 3 cubed divided by 3. So the first one is 90 minus 3 to the power 5, 243 over 5 minus 10 over 3 plus 1 over 5. So this will be 287 over 150, or roughly 1.913. So now you need to find the standard deviation. Easier way is to find the variance first. So this will be integrating from 10. So you need to multiply x squared inside. So 10x cubed minus x power 5 dx. So this is the first part, and you need to integrate from 1 to 3. And then minus the expected value square. So let's integrate the first part. You would get 10x power 4 divided by 4 minus x power 6 over 6, 3, 1, 287, 150 square. So I will calculate this directly using my calculator. Just give me a second. So minus 10 over 4 plus 1 over 6. So the first part gives us 59 over 15. So if you minus that one out, this will be okay. Let's round it. Let's write down the decimals. So standard deviation will be the square root of that. So you should be able to get 0.5220 if you put it for 4 decimals. So that's your mean and standard deviation. Find the probability that the length is less than the mean. So part B. Find the probability that the length is less than the mean. So the mean is 1.913. So what you will need to do is to integrate from, so let's write down 1 over 20. 1 to 1.913. 10x minus x cubed dx. So 10x squared divided by 2, you'll get 5x squared minus x power 4 over 4. 1.9131. Give me some time to compute it. Minus 5 plus 1 over 4. So you will get 0.50, so 51. Because it's 5099 something, so it's 51. So that's the probability. Customer require component with length that are within 1 standard deviation of the mean. If you have a batch of 1000 components, how many will be acceptable? So part C. So 1 standard deviation from the mean. How would you formulate that? That means that your mean is 1.913 and your standard deviation is 0.5220. So the equation that you need to write is the mean. So the mean minus standard deviation x, and then the mean plus the standard deviation. So this is the equation that you need to write. So let's plug all the numbers inside. So you have 1.913 minus 0.522, which is 1.391, and then plus, so that would be 2.435. So these two values are still within 1 to 3. So then what you need to do next is just to integrate this from 1.391 to 2.435, 10x minus x cubed dx. So this will be 5x squared minus x power 4 over 4. And you can calculate that. So give me a second to calculate. Five times 2.435 square minus 2.435 power 4 divided by 4 minus 5 times 1.391 square plus 1.391 power 4 divided by 4. So what you should get is 0.6059. So that is your probability. So now you create 1,000. So this particular number multiplied with 1,000, the expected value would be 605.9 or 606. So that would be the answer. So that's all for this chapter. Thank you.